The idea of quantum computers redefining reality is a mix of tech hype, physics weirdness, and philosophical rabbit holes, so let's break it down step by step. First off, what are quantum computers? Unlike your laptop, which uses bits to represent data as either zeros or ones, quantum computers use qubits. These qubits can exist as 0, 1, or both at the same time, thanks to a quantum mechanics trick called superposition. They can also be entangled, meaning the state of one qubit can instantly affect another, even if they're miles apart. This lets quantum computers process insane amounts of data in parallel, potentially solving problems that would take classical computers billions of years. We're talking cracking encryption, simulating complex molecules, or optimizing systems like global logistics in ways we can barely imagine. Cool, right? But does that redefine reality? Let's unpack that. When people say redefine reality, they might mean a few things. One angle is practical. Quantum computers could transform how we interact with the world through technology. For example, they could break current encryption methods like RSA, which secure everything from bank accounts to government secrets. If that happens, our digital infrastructure, aka the backbone of modern society, might need a complete overhaul. Imagine a world where no password is safe unless we develop quantum-resistant encryption. That's not reality bending, but it's a seismic shift in how we live, work, and trust technology. In medicine, quantum computers could simulate molecules so precisely that we discover new drugs or materials, potentially curing diseases or creating sustainable energy sources. This could change our physical reality, healthier lives, cleaner planets, but it's still within the bounds of what we call reality. Another angle is scientific. Quantum computers could let us model complex systems we can't yet fully grasp, like the behavior of particles in a black hole or the universe's early moments. Quantum mechanics itself already challenges our intuitive sense of reality. Think Schrodinger's cat, where something can be in two states until observed. Quantum computers might deepen our understanding of those principles by running simulations we can't do now. For instance, they could help test theories in quantum gravity, which tries to unite quantum mechanics with Einstein's relativity. If they uncover new truths about the universe, it might shift how we perceive reality's fundamental rules. That's heady stuff, but it's more about refining our understanding than rewriting the laws of physics. Now, the philosophical angle is where it gets really wild. Some folks wonder if quantum computers could push AI to a level where it starts mimicking consciousness or creating simulations so advanced we question what's real. Picture an AI powered by quantum computing that can model entire universes or make decisions so complex it feels alive. If we start relying on these systems to predict or shape our world, we might blur the line between human choice and machine output. This ties into the simulation hypothesis, the idea we're already living in a computer-generated reality. Quantum computers could, in theory, make such simulations more feasible, sparking debates about whether reality is real or just code. But let's be real, we're nowhere near that yet. Current quantum computers, like those from IBM or Google, have dozens of qubits, are error-prone, and need super cold environments to work. We're talking early days, not Matrix-level stuff. There's a flip side, though. The redefining reality claim can get overblown. Quantum computers don't change the laws of physics, they exploit them. They're tools, not magic wands. They won't make the sky fall or turn cats into quantum overlords. Some hype comes from pop science or companies pushing their tech to sound revolutionary. There are also risks. If quantum computers make AI hyper-intelligent or disrupt cybersecurity, they could destabilize economies or geopolitics. That's not redefining reality so much as reshaping society, and not always for the better. Plus, access to this tech might be limited to a few big players. Think governments or megacorporations, widening power gaps. That's a practical concern, not a metaphysical one. So, will quantum computers redefine reality? Not in the sci-fi sense of altering existence itself. They could transform how we interact with reality through tech breakthroughs, scientific insights, or societal shifts. But they're grounded in the same physical laws we've always had. Reality's still reality. It's just that our tools for navigating it are getting a major upgrade. Long term, they might make us rethink what's possible, from curing cancer to exploring the cosmos. But we're talking decades, not tomorrow. What's got you hooked on this idea?